So we're going to round out day one by taking a look at the equation that was the one that really caught Einstein's imagination and was the one that turned him around so dramatically. So, from theory, with electricity and magnetism, people were able to calculate the speed of light. And that equation is as follows. So the speed of light, c, is, the fact that it's 1 over the square root isn't all that important for these purposes. What matters is the speed of light can be determined completely based on two quantities. So there's the electrical permittivity of free space, which is this epsilon naught, and there's the magnetic permeability of free space, which is mu naught. So these two numbers represent how easily electrical and magnetic fields can penetrate the vacuum. So how strong the fields are, how well they transmit. The subscript zeros are there because different materials will have different values for this. So the zeros say we're dealing with a vacuum. If you just have mu without zero, well, that's the magnetic permeability of a particular material. Same with the epsilon without a zero, that's the electric permittivity of something without a zero. But Einstein was the one who looked at this, and he realized the implications of this algebra far before anyone else. If we think back to our very first lesson, in the first part of this, we were talking about reference frames. We had someone on the park bench reading a paper, and we had a car driving by with its headlights on. And the person on the bench and the driver of the car disagreed on how far light from the headlights had gone. They agreed on how long it took to get there, so they disagreed on the speed of the light coming from the headlights. And that's because their frames of reference are different. But the frame of reference comes into things like position. It might be time for when you start your stopwatch. These values depend on frames of reference. But these two values, the only two numbers you need to calculate the speed of light, these numbers are completely independent of your frame of reference. The magnetic permeability of free space is the same for everyone. The electric permittivity of free space is the same for everyone. As a result, the speed of light has to be the same for everyone. So this light that was emitted from the car moves at speed c. That doesn't matter if you're stationary on the park bench measuring it, or if you're the driver of the car measuring it. They do not agree on how far the light has gone, but they don't agree on how far the light has gone, but they do agree on the speed. The ratios are the same. So therefore, because they don't agree on the distance, but they do agree on the ratio of distance and time, they cannot agree on the time elapsed. This completely changed everything from a physics perspective. This is the key that actually drives the theory of relativity. It was Einstein realizing that the speed of light is what we call an invariant. It doesn't matter which photon you're looking at, it doesn't matter which direction the photon is moving, it doesn't matter how fast you're moving or which direction you're moving. If you measure the speed of light of that photon, and it's traveling through a vacuum, you are going to get the speed of light, the one and only speed of light for that speed. Now, if we remember from refraction, we'll find that if it's traveling through a material, say glass or diamond, then yes, light does slow down in that material. But in a vacuum, every photon, as measured by every possible observer, travels at the speed of light. And this revelation is the one that completely turned over the entirety of physics. In doing so, we had to throw out Newton's reference frames and restart from scratch. So that's going to be a lot of what happens in day 2's videos, is understanding what are the differences in these reference frames, how could we build them, what is coming next. So we'll start to deal with that in much more detail tomorrow.